Okay, so we're working on problem number 10, and it says that we need to use appropriate tools strategically. So, since we do not have calculators, if we were in the classroom, we would use the calculator, but since we're not, we're going to use a program on the computer. This is just GeoGebra. Let me show you. I'm not going to give you the website because you can just Google it. You can go to Google and type in GeoGebra, GeoGebra, and you just press enter, and it brings you up um, with several links. I think I just said geometry. I don't know if that's what I did or not. Yeah, I just click the geometry and it takes me to a calculator page. And so we're going to go from here. I already had it pulled up, but I'll just use the one that I just pulled up with y'all to show that you can start anywhere. Okay, so what we're gonna do, this is really cool. You just hit this little polygon button and be sure you know what it is we're supposed to be doing. It says, um, use the geometry software to explore reflections. First, use the software to draw a pentagon. So we got to draw a pentagon, then we draw a line of reflection that passes through one side of the pentagon, and then use the software to do a reflection. So here we go. First thing we're going to do, it said pentagon, right? So you click on polygon right here, and I believe, and you just start clicking anywhere. A pentagon has a 5. So that's a pentagon, has points A, B, C, D. It did say pentagon, didn't it? Pentagon, okay. And then it says draw a line through one of the sides, and it totally doesn't matter. It just seems like this side right there is a nice side to reflect about, so I picked that one. And all I did was select the line and then picked 2 points. That's all you need to draw a line or 2 points. I'm going to come over here and click more, and I'm probably going to have to scroll down a good bit. Here we go for transform. We want to reflect about the line. So we click that, nothing happens. Well, that's because it wants to make sure that it knows what it is you want to reflect, what we're going to reflect. So we're going to click on the pentagon, and then we're going to click on the line. And that tells GeoGebra that we want to reflect the pentagon about this line. All right. So we have done everything that I think that first problem asked us to do. Use the software to reflect the pentagon over the line. So we did. We got a pentagon and we reflected it over the line. What happens under this reflection to the points that lie on the line of reflection? So they're asking us what happens to these 2 points right here. Remember, they were called points A, B, C. It was D and E. And now it's A prime, B prime, C prime, D prime, and E prime. So what happened to those 2 points? Well, nothing. Since they lie on the line of reflection, they map, we say, to themselves. So they map to themselves. Okay, the next question, I believe, says use the software to explore how points not on the line are related to the image. And it tells us to measure the distance of a point to the line of reflection. So GeoGebra will find a distance for us. So we just have to come up here and we want to measure a distance or length. So we're going to measure the distance from C to the line. And it measured Now, I want you to pay attention. This is very interesting. Let me see if I can move that out of the way. Can I move it? I won't let me move it. Notice it's telling me right here what the measure is. Did you notice that the line right here is named with a lowercase italicized letter? That F doesn't look very italicized, but it is. So it's showing me right here that the distance from C to F is 1.8. I don't know what the units are. Centimeters, maybe? I don't know. 1.8 units. Well, let's measure the distance from, and as long as this is highlighted over here, I'm still measuring the distance. And by the way, I will show you where this distance is in just a second. We're measuring the distance from C to F again, and this time it's showing me from C prime to F is 1.8. So I want a line to measure the distance from a point to a line. It has to be a perpendicular line. So let me see if I can get, okay, and there. So I drew a line perpendicular to F. Okay, I drew a line perpendicular to F, and then I measured the distance from that point right there. Okay, let me do a measurement again. Where did measurement go? A length, a measurement from here to here. See, it's still 1.8. Now they capitalized it, and the reason that they capitalized it, I wish I could move that. Okay. They won't let me move it, but underneath this label right here is the point F. I can see it right there. It's hard to see. So fine, I'm going to do the same distance again. I want to do this point right here to this point right here, and it named it F to C prime is 1.8. So, and you can see right here, you can just see kind of, let me do a perpendicular line to this one. Okay, and then I'm going to slide it over. There we go. And now measure the distance from A to G is 0.9, and from A prime to G is also 0.9. So what were we supposed to discover? And you could do the same thing right here for B. What were we supposed to discover or investigate? It says measure the distance of a point to the line of reflection. Then measure the distance of the point's image to the line of reflection. What do we find? They're always equal. Draw the segment that connects a point and its image. How is this segment related to the line of reflection? Well, I kind of spoiled that because we've already got those points right there. And what's the relationship? It's perpendicular to the line of reflection. So the line that connects a pre-image to an image, that line that connects the pre-image to the image will always be perpendicular to the line of reflection. So this is a hot mess because I can't get rid of those labels. And I know that I can move those labels. How about we just don't show it? Well, if we don't show it, then we can't. Let's see if we can remove it. I want to move it. Show object. I don't know. So we've done everything that we were supposed to do for 12. And then that leads us to what's the difference in this picture right here? It does not have a coordinate plane. So since it's not on a coordinate plane, we can still have lines of reflection. And let's see if I have time to finish this one. It says So here's some information. Like other transformations, reflections can be defined independently of the coordinate plane. In other words, we don't have to be on the coordinate plane. A reflection is a transformation that maps P to P prime across line L such that, so what's going to be the conditions? P is not on the line, not on the line of reflection, and the line is perpendicular to, is a perpendicular bisector of, so it's the same thing that we just saw on the um, computer, the GeoGebra that we did. So if these two right here are reflections, then when we connect those two, exactly halfway between those two and perpendicular to the line that connects those two is where we will find the line of symmetry. So let's let any point that we want to pick, let's let the point that we want to pick right here be A, and let's let this over here be A prime. Remember, P just stands for any point. So the point that we're picking up right here at this time is A. So connect A to A prime. Okay, that's not a horrible connection. It's not perfectly straight, but it's pretty close. And then if we had a ruler or if we had a compass and we could bisect it, then we could certainly do that. But this time we're just gonna have to eyeball it. Halfway in between and perpendicular to that line needs to be L, which is the line of reflection. So in other words, whatever that point is right here, this piece is equal to this piece, and these two right here form a 90-degree angle. So if the distance from an pre-image to its image, find the midpoint of that distance, then find the perpendicular, the line perpendicular, and you will have the line of symmetry. I'm sorry, the line of symmetry, yes, but the line of reflection. Symmetry is a word that's coming up here in just a second. So notice that here's that lowercase script r I've been trying to draw. So the lowercase script r is being reflected about line L. And we drew law L, label the points A prime, B, this, we reflect this point to this one, that's B prime right there. We reflected it over there, so this is going to be E prime over here. This is going to be C prime right here and D prime right here. We did all of that. Okay, let's see. We've got quadrilateral ABCD was constructed by drawing a scalene triangle. You know what scalene means? Means none of the sides are the same length. So A, B, C, all three of these sides are different lengths. Then we drew its reflection across BC. So this was the pre-image. This is the image over here. Point P is the intersection of BC and AD. Prove that BC is perpendicular to AD. Okay, well, these two right here, since this is the reflection, this is the pre-image over here, this is kind of like calling this A prime. It's the image of the pre-image. And so what did we learn that the line of reflection did? The line of reflection is halfway between the pre-image and the image. It's halfway, so that means these two pieces are equal to each other. And we also learned up there that it's perpendicular. So that is BC right here is perpendicular to AD because BC is the line of reflection and AD is the mapping, or is the line that connects the mapping of A to A prime, or A to D in this particular case. Explain why AB is equal to BD. Well, it is a reflected image. AB is the side of the triangle, and its reflected image over here is BD. So they are going to be the same length. Because remember, what kind of motion is reflections? It's rigid motion. So we don't change the size of the image or the pre-image. We don't change the size of the pre-image with the transformation. It's rigid motion. So that's why those two are equal. All right, so I'm going to stop the video because the next thing that we're going to talk about is symmetry, lines of symmetry, and I think that's going to finish up this activity. It's been a really, really long one. So yeah, I will see you in the next video talking about symmetry.